Hello guys, you're welcome to my channel. So we are going to continue from where we stopped. In our last class we look at question 1 and 2. So today now wants to look at question 3 and 4. So you can find the link to question 1 and 2 in the description box below, coupled with the topic vector and scalar link. Okay, the third question says two forces 3 Newton and 4 Newton act on the body in the direction due north and east respectively. Calculate their equilibrant. Now I would like us to understand what we call equilibrant like we explained in that class. Equilibrant is a single vector that is going to balance the system of 3 or more vectors acting at a point. That is what equilibrant is. And you need to understand the following properties about equilibrant. Equilibrant has the same magnitude as resultant, but opposite in direction. Now let's see. Solution to this question thus. Two forces 3 Newton and 4 Newton acts on the body in the direction due north and east respectively. So when I say due north and east respectively, it means that 3 Newton is acting due north. So we have this. 3 Newton is acting due north. East, it means 4 Newton is acting due east because we are told that the direction is respectively. Now, or possibly, for me to make this more comprehensive, let me put the direction east downward like this. So I have 4 Newton here. Okay, if this should be the case, here is going to be the point at which the two vectors 3 Newton and 4 Newton act together. Hence, I have my resultant to be here. So if this is angle theta, from here down like this, here would also be theta. So this place is 3 Newton. If I cover this place up, here would also be 4 Newton. So I'm having two right angle triangle here. If I'm considering O, A, B, and C, if I will consider O, A, C, here is my angle, which is the direction of the two vectors. And if I'm considering C, B, A, here will be my direction as well. So whichever one you are trying to consider, you will still arrive at the same answer. Now, let us consider the right angle triangle OCA, or possibly I can also decide to consider right angle triangle ABC. I think that is more pronounced. So consider right angle triangle ABC. So if I withdraw my right angle triangle ABC, I will have this. So this is B, this is C, and this is A. So I have my angle theta here. So we have this, and we have this. So this is R, here is 3 Newton, and this is 4 Newton. So the first thing is to look for the resultant. So resultant is going to be R square equal 4 square plus 3 square. So R square is 16 plus 9, and that will give us 25. I'm using Pythagoras theorem. So R is the square root of 25. So R is said to be 5 Newton. Now the magnitude of the resultant is 5 Newton. Remember, we are looking for equilibrant, not resultant. Now, let's determine the value for the direction of the resultant. So, the direction of the resultant is given as the tan of this angle, theta, to our opposite, which is 4 Newton, divided by the adjacent, which is 3 Newton. This and this would cancel. So I have that tan of theta is 4/3. And 4/3 is 1.33, right? So tan of theta is 1.333. Hence, theta is arctan of 1.33, and this should give us 53.1 degree. So if we have that theta is 53.1 degree, what would then be the direction? So let's look at this. If this is our cardinal point, you know that from here to this place is 90 degrees. So 53 degree will fall somewhere here. So I have this. And if you look at it also, you see that it's the same direction. So if I have 53 degree here, it means that the resultant is moving in the direction north 53 degree east. So if the resultant is moving in the direction north 53 degree east, and you are told that resultant equilibrium that we are looking for has the same magnitude as resultant but opposite in direction. Hence, if resultant is in north 53 degree east, equilibrium is going to be south 53 degree west. Are we together? So our result is going to be that 5 Newton south 53 degree west. So this will be the value for the equilibrium of the two vectors 3 Newton and 4 Newton. I believe we understand this. Okay, let's move to the next question, question 4. One thing that students always find difficult in physics is that when you see diagram, it seems it's complex, but as a matter of fact, when you see diagram in physics, it makes your question more easy to attempt. Now, let's look at what we have there and let's put solution to that question. Now, if you look at the diagram, we see that this body is at equilibrium. But don't let us look into that now. Let's read the question. It says, a 15 kilogram mass suspended from a ceiling. This is the ceiling here. And this is the mass suspended. Okay? Is pulled aside with a horizontal force of, with an horizontal force F, as shown in the diagram above. So we pull this particular ball, this particular mass of 15 kilogram aside with a force of F. This F, we don't know the value, but it's an horizontal force that we use in pulling this particular mass. The question now says calculate the tension value T. The tension on this particular string that we use in suspending this mass, we are asked to look for the value of the tension if the acceleration due to gravity is given as 10 meters per second square. Okay? How can we go about this? The first thing we need to consider is what is the line of action of this tension? You will agree with me that the line of action of this tension goes in this direction. If the line of action of this tension goes in this direction, and I have I have the mass of the body to be 15 kilogram, you will see that this and this, they are like this. If you look at this, they are making an angle here. But what will be the value of this angle is what we don't know yet. But if you look at this line, it's said to parallel to this. If this line is parallel to this, hence, if this angle is 30 degrees, here is also 30 degrees. Okay? If this place is now 30 degrees and here is 15 kilograms, let's talk about the weight of this body now. The weight of this body is going to be 15 times what? Times 10, because weight is mg. Let's put it like that first. If this place is mg, this place is said to be mg cos theta because it's adjacent to this. And the tension is what we have here to be mg cos theta. So here is also going to be mg sine theta. Here is mg sine theta because it's the opposite side to the angle. So the opposite side to the angle is mg sine theta, because if you look at this and this are perpendicular. This line and this line, they are perpendicular. So this place is the hypotenuse. If here is angle and here is opposite, the opposite of the angle is going to be mg sine theta, and the adjacent will be mg cos theta. If you don't understand what I'm doing there, let's see. If I'm looking for the value of this opposite, which is the horizontal force F, and I know this particular weight to be mg, and I know this angle, so I can apply the SOHCAHTOA. So I'm going to have that sine 30 degree is so opposite, which we know as F, because we are told that F is the horizontal force. So this is F, opposite over hypotenuse, which is mg. So F is going to be sine 30 degree. Okay, let me put it like this: mg sine 30 degree. Mg sine 30 degree. Let me call this equation 1, and you see this now. Now the tension is adjacent to this angle. So we have that cos 30 is the tension T divided by the hypotenuse mg. So we have that T is mg cosine of 30 degree, and this is the second equation. Okay guys, you will now see that we are right with what we are saying earlier, that this place is going to be mg cos theta and here is mg sine theta. I believe you get the explanation on how we get that now. Okay, you are still finding it difficult. Why is it that this place is 30 degree? Because this and this are parallel. I'll make some video on trigonometry and line geometry, so you understand more about angles and triangle. Okay, let's come back to this place now. We are looking for the tension. So tension is given as mg cos 30 degree. So the tension on that particular string is going to be 15 times the g is 10 cosine of 30 degree. So T is going to be 150 cosine of 30 degree. So that will be 150 times 0.866. So T is going to be, so let's quickly look at the value for that. 150 times 0.866. So we have 129.9 Newton. So this is the tension on the string. Okay, what if the question now says you should look for the horizontal what? The horizontal force T. How can you go about that? Okay, for us to look for the horizontal force F, we can just slot in the value of M. So we are going to have that F is equal to the mass, which is 15 times the gravity 10 sine of 30 degree. So we have 150 into 0.5, because sine 30 is 0.5. So the horizontal force is going to be 75 Newton. Okay, now let's see, is there a way we can check if our answer is actually correct? Now, this place gives us what? 150. Let's see if this is a right angle triangle. If this is a right angle triangle, like it is a right angle triangle truly. So we have this place now to be 75 Newton, and we have this place now to be 129.9 Newton, and we have here to be our resultant. How can we find the value of this resultant? We can simply say that 75 square, that is R square, is going to be 75 square. Okay, let me make that with another marker. Okay, so if I have R square to be 75 square plus 129.9 square, so R square is going to be 75 square is going to give me what? Okay, I have 5625 plus 129.9 square. Okay, 129.9 square, I have the 168740. Okay, 4.0. Yes. Okay, if I have these two together, what am I going to have? Plus 5625. Okay, let's take the square root of the summation. So if I take the square root of the summation of these two, that is 5625 plus 16874.0, so what will be my value? So I'm going to have 149.99. So if you look at this is already what? Approximately 150 Newton, which happens to be the weight of this. So if that should be the case, this marks the end of the 2 questions for today. So kindly subscribe to this channel. Thanks for watching the video and liking the video always. We are here to serve you. Thank you for watching. Kindly share within your friends and subscribe. Have a nice day.